Hi, this is Rachel Romeliotis. I'm a senior editor at O'Reilly Media, and I am here with Glenn Block. He is formerly a program manager with the ASP.NET Web API team, and he is now a senior program manager with the Windows Azure team. Thanks for joining me all the way from Shanghai, China.
Yes, thanks, Rachel. It's great to be here.
All right, well, we got a lot of questions for you, so I'm going to just dive right in. So the Web
Sure.
API framework just launched. Why would a developer use
Yes.
this over web forms or MVC?
So that's a great question. What Web API really is designed for are when you have clients that are beyond just browsers that are consuming lightweight services over HTTP. And we see a big trend. Nowadays, a lot of browser applications are actually these more rich client applications running in the browser where the web server returns some static HTML, and then maybe it uses a client-side framework like jQuery or Backbone or Knockout.js to then make calls back to the server to pull back data or to access functionality. And so in that case, the web server's role is really not so much about serving up pages. It's really about accepting data and returning data in different formats. And you might have clients which are not just browsers, like mobile devices, or even headless devices, like some type of embedded process that's running somewhere. So what Web API really is about is enabling a rich set of clients to be able to consume information, whereas ASP.NET traditionally has really been about clients consuming HTML. It can do other things, but it's not really tailored for non-browser-based clients. And when you have a rich browser client like I talked about, the thing that's doing the consumption is actually JavaScript. So it's not the traditional like HTML just in the browser. It's really a program that's executing in your browser. So that's really the primary difference.
Interesting. So yeah, that was actually my next question was what are the major differences? So I think you outlined that right there.
Well, I can go a little bit further.
Sure.
MVC is actually very page-oriented, whereas Web API is not. And what that means is like Web API, like in MVC, it'd be very common to have, say, an action. Like I might have a page which allows me to edit orders. So I might have a URL. And this was something that was very popular also in Ruby on Rails, where I might have orders/edit. And so edit corresponds to an action. Whereas with HTTP, there's actually a uniform interface that defines how you interact with a resource. You have standard HTTP methods like get, put, post, delete. So the primary difference with Web API is with Web API, when you interact with a resource, you're primarily using those HTTP methods. So if you want to push data, you'll do a post. If you want to pull data, you'll do a get. If you want to update the state of a resource, you'll do a put. Mm-hmm. So that's really a big difference, is that when you build traditional web pages, you don't think about a lot of that stuff. You just have a page and you create URLs for every different kind of action that you want to do. Whereas with a web API, you really are sticking closely to the semantics of HTTP. Mm-hmm. For some benefits that you can get. For example, when you do a get in HTTP, that response is cacheable. But when you do a post, that response is not cacheable. With Web API, you can basically say, hey, here's content that I want to be cached so that even if it's being accessed from some JavaScript code running in a browser or from a mobile device, that client can cache that result and can actually communicate back to the server using standard HTTP mechanisms to basically see if that cached item is still valid, or see if it's expired, etc. It's just one example.
Mm-hmm. Next, let's see. So, and again, sort of along the same lines, can you talk a little bit more about why this is easier and better, and continue to sort of sell the developer on why they should use this?
Sure. I think the thing is this. So a lot of people will ask the question of, hey, I've been using MVC and returning a JSON result for my little jQuery pages. Why do I need to use Web API? And I think that's actually fine if that's what you're trying to do. But if you're really trying to have a full, rich API that can be consumed by different types of clients, MVC in the box at least is going to start to fall down very quickly. Now, yes, you can write a bunch of extensions to try to do things, but the point of Web API is it actually gives you a proper experience for doing all those types of things. So if you're building out an API like Facebook, for example, you're going to find it much easier to do that with Web API. You're going to find that a lot of the things that you expect to do are naturally there. Whereas in MVC, traditionally, it's possible to do it, but you're going to be doing a lot of work, and you're kind of going against the grain of what MVC was built for.
All right. Good answer.
I'll give you one example.
Sure.
We're going to talk a little bit. I know I'm imagining you're going to ask me something about content negotiation, so I'll jump ahead of the gun on that. Content negotiation is the ability for clients to ask for different formats of data. And HTTP defines the way that they can do this. They send accept headers. So one client might say, I'd like to get that data in XML. And it can send an accept header that says application/XML. Another client might say, I'd actually prefer to get that in JSON. And the server can be designed such that it can respond to either XML or JSON. A third client might say, you know what, I'd like a PDF. If you can give me a PDF, I'd prefer a PDF because I'm a PDF reader. And it can actually specify a whole prioritization of what types of formats can be supported. Now, in ASP.NET MVC, if you wanted to write a service that could do that and take advantage of using accept headers, which is the way that the HTTP spec really specifies to do it, you're going to have to do a lot of work. There's nothing in the box to do that for you. Whereas in Web API, we have this concept called formatters. And you can plug in as many formatters as you want. You can write a formatter for Atom. You can write a formatter for a custom representation that you support. One of the common things I would demo when I showed Web API was vCard. And vCard is a popular format that even tools like Outlook understand how to import and export data in. So with Web API, it's extremely easy to just plug in a vCard formatter. And then if a client comes with an accept header that says, I want vCard, which would be text/directory or text/vCard as the media type, then it can just say, cool, I've got a formatter that will do that for me. Those are the kind of things that become really important when you start to support lots of different clients, that you're really going to be bumping your head up against the wall in MVC. There are people that have done it, but they're doing it through building their own add-on frameworks because of the fact that it doesn't natively support that kind of functionality. Whereas in Web API, it does.
So it just sounds easy.
Does that make
for
sense?
The developer. Yes, definitely.
Yeah, we talk a lot about at Microsoft this concept of the pit of success, making it really easy, like a pit. I love this. Rico Mariani, who's one of our really senior architects at Microsoft, coined this term, pit of success, with the idea that, a pit is usually a bad thing. You fall into a pit and maybe you get hurt. But the concept of pit of success is leading people where, hey, when they fall, they actually find they're in the right place. And I would say that with Web API, we have that principle there, which is like, if this is what you're trying to do, then you're not going to be, then you'll fall into the right place. It will naturally bring you there. Whereas with MVC, if this is the thing you're trying to do, it's not going to naturally bring you there. It may support it, but you're going to have to do a lot of work to make it get you where you want to be.
Cool. Let's see. What else do I have here? Oh, I wanted to ask you about hosting and self-hosting. I know that's actually a pretty big deal in this as well.
Yes. A lot of people ask, why is self-host a big deal? Well, what self-hosting basically means is it's not requiring IIS. It's not requiring you to have a full-blown web server installed on the machine. One of the reasons that's interesting with our cloud story is if I deploy to Windows Azure and I want to use a worker role, which is a common pattern in Windows Azure if I'm doing background things, and a lot of people think of services as background type things, then IIS is not present. So previously, if I wanted to do that with MVC, it was next to impossible for me to do it. It was you have to write so much code. There are interfaces that would allow you to abstract out MVC, but it's no human being is actually going to do that. Whereas with Web API, I could simply just spin up a self-host running in Windows Azure worker roles, And then I can have my web API running, and I don't need IIS at all. The other reason that's attractive is there are people that just don't like IIS. They think it's too heavyweight. And so one of the things that Web API is also opening up the ability to do is not only to self-host, where you're just listening over HTTP Listener, which is the built-in kind of networking stack in Windows, but there are these open source servers out there, like Kayak is a well-known open source web server. And with Web API, I can actually host my Web API on top of Kayak, which is just giving flexibility, giving developers the choice of saying, hey, if I don't want to use the default Microsoft answer, I don't have to. And whereas IIS wouldn't work well in Worker Role, I can easily run Kayak in Worker Role. So it's really just about giving flexibility.
That's great.
So that's the self-host story.
That is wonderful. Let me see what else I had. Oh, okay. Another kind of specific question was, can you tell me about the HTTP programming model?
Absolutely. So if you look at a lot of other stacks, like if you look at Ruby, if you look at Python, there's the concept of an HTTP client. And that client is a way to basically consume other types of web APIs that are out there, being able to nicely make HTTP requests and return HTTP responses and work with those responses. A lot of those languages are dynamic languages. In the .NET framework, we haven't really had a good answer. The prior answer has been this thing called HTTP web request. And people always felt that HTTP web request was weird because you don't actually have a notion of a client. The web request has a method on it that says, like, get the response. And it was very hard to unit test against because the web request itself is bound completely to working with the HTTP stack. And there was no easy way to, like, pass messages around. And the other thing is, it wasn't really strongly typed. All the information was just like bags of data. It was just like a very loose kind of dictionary thing. But we're in the .NET framework. We're in C# where we expect, or VB, where we like to have the static typing that .NET has to offer. So one of the things that the new HTTP program model introduces is strongly typed abstractions for working with HTTP requests and HTTP responses. And it introduces an HTTP client that you can use for sending those requests and sending those responses. It gets really interesting because then those requests and those response objects can be used on the server or can be used on the client, which we've never had. The same exact programming model you can use on the client or you can use on the server. The client itself, though, another thing that we got a complaint about with the former programming model is that there's no pipeline. Often when you're building systems over HTTP, you want to intercept the request. You want to tack on some headers or inspect some headers or manipulate some of the contents before the message goes out the door. And with the new programming model, you actually have this pluggability point called message handlers, and they're chained together. So I can actually go to my client and I can chain in custom code that will manipulate the message or inspect it before it goes out the door. And one of the reasons it's really interesting from a unit test perspective is I can actually plug in a message handler that is no-op, that basically just returns a dummy message in a unit test. So this way I'm not actually creating a HTTP request that I'm sending across the network when I'm in my unit test. This speeds up my unit test, but it also minimizes the amount of setup that I have to do because previously I would actually have to have a real service up and running which can listen over the network, even if it was on my local machine, to be able to generate those requests. So it really makes testing much easier. And people just find that the new programming model makes it much easier to do the kind of things that you want to do with HTTP. And I'll give you one example, which I talked a little bit about earlier, this concept of caching. So HTTP has this model for caching, which utilizes these things called e-tags. And an e-tag is where I generate, whenever I return a response, I want to embed an e-tag, which has a unique identifier, which identifies this representation that I'm returning at a point in time. A client can save that e-tag, and then in the future, they can send me a conditional GET request where they pass me an if match or an if none match header that contains that tag. Then when the server receives it, the server needs to inspect that and say, oh, if you've sent me this if match or if none match, I'm going to check to see if the ID that you sent me is still valid for the thing you're trying to get. And if it turns out that the cached item you have is still valid, I'm just going to return you a status code that says not modified. So with the new programming model, it's actually really easy to get in the middle both of that request and that response, to just sit there and inspect the response as it's going out the door and say, great, I'm going to tack on an e-tag so that the client gets the e-tag. And then on the client side, when the client sends the message, I can have a message handler on the server that inspects that and says, if you sent me an if match or an if none match header, I can do the algorithm to determine if the key that you gave me is still valid, and if it is, I just return the status 304 not modified. So this is an example of the types of things that there was no easy way to do this kind of thing, say in MVC, and even if you could, the programming model wasn't as nice. So this is just a very new programming model. It is modeled after the most up-to-date specs around HTTP, and it is really easy to work with and really flexible to do more advanced things.
Well, it sounds like there's a lot of stuff to be excited about right away, but my final question is, where do you think the future is for Web API?
That's a great question. I think you're going to see Web API start to become more and more prominent. A lot of people have said that when they look at Web API today, they say, you know what, HTTP is one thing. Why should I have two frameworks? Why should I have a framework for generating web pages and a different framework for my web APIs? There have been a lot of people that have been vocal about this. And one of the simple answers for that is that Microsoft just doesn't want to break all the existing customers that are out there. We have a lot of customers that have invested in using ASP.NET, using ASP.NET MVC. And with Web API, we wanted to say that, hey, for those existing customers that then want to add an API to their existing systems, they don't have to throw out what they have. They can just add that on, and it will light up, and it will work fine. The other thing was we made major enhancements to Web API to make it support task of T, which is the new async programming model. Like Web API supports task of T top to bottom. Making those kind of changes on the existing ASP.NET infrastructure would have been a tremendous breaking change. So we decided not to do that breaking change. Also for timing, I think we said, okay, we've got ASP.NET, which is great for websites. We'll use Web API for doing more of the, data type things. But there are a lot of people who've said, you know what, it'd be great if I had one stack. And I think over time, you're going to see more and more of that functionality get into Web API, where you'll be able to not only use it just for web APIs, but you'll also be able to think of your website almost as an API. You'll be able to say, hey, I can also serve up HTML and do a lot of this stuff, but it'll do it in a very HTTP-friendly way. So I think that's one of the things you're going to see. The other thing I think you're going to see is there's a lot of energy around this thing, which we talk about in the book, called hypermedia. And hypermedia is this ability to build systems that really communicate with each other, links that allow clients to determine what's available for them to do next. And it does it in a way that doesn't create a hard coupling between the client and the server. And it's a big topic in its own right. But Web API, you can build a hypermedia-based system, but it doesn't have a lot out of the box. Like it has the fundamental pieces that make it easy, if you understand hypermedia, to plug those pieces in. But the pieces themselves don't exist in the box. I think you're going to see over time those pieces are going to show up more. Some of that is appearing in the OData functionality, which we've recently announced, which is a preview, which is an add-on to Web API that allows you to return, to have your Web API support the OData spec and the OData protocol. But I think you're going to see more beyond just OData, just general infrastructure. The other thing I think you're going to see is the community with Web API Contrib is also going crazy with ideas on the things they want to see. For example, the thing I just told you about using your Web API to generate web pages, somebody's already written like a Razor formatter, a view engine formatter that allows me to plug in Razor. So I think you're going to see both on the community side and on the Microsoft side definite progressions in some of the areas that I talked about.
That is really cool. And you mentioned the book, and I want to mention that just because we want to get as much feedback as possible. So the book is going to be available for pre-order, but also we're going to have it on our OFPS program, and so that's ofps.o'reilly.com, and it's free to take a look at, and you just sign up, and we want to hear your feedback because we want to make the book as great as possible. So I think that will be great fun and will be helpful. And so I want to thank you so much for taking the time to talk to me, and good luck over there in Shanghai.
My pleasure, Rachel. Thanks.
Thank you.